Hello and welcome to some homework questions from the My Math Lab, section 5.4, which is about indefinite integrals. Part of the reason I'm doing this is because My Math Lab has chosen actually some questions from 5.5 to put in 5.4. So we need to be using U substitution. So luckily, they even tell us what to use for the U substitution. So let the U equal x squared plus 3. And then take the derivative of that, and the derivative is going to be 2x. And the first time I do it, I say this is supposed to say du dx, and then the next step is to multiply the dx onto this side, but you can save a little bit of time by doing that all at once. And then if you look at the question, it has 2x dx, which means this is a straightforward U substitution. We don't need to adjust this at all. So this is going to be integral, and then this part here is going to be the u raised to a negative 11. And then the 2x dx, that whole thing gets replaced with just du. And then you can add 1 to the exponent. That's going to be a negative 10, and then divide by negative 10. So we would have negative 1/10. And then the u is to the negative 10, and don't forget the plus c. And then two little things to finish this up. One is I need to replace the u with the x squared plus 3. And also, I don't like to leave negative exponents, so I'm going to write it as negative 1 over a 10, and then replace the u with x squared plus 3. And then it's raised to the 10th. Now that it's in the denominator. And don't forget the plus c. So another one from section 5.4. So again, this is section 5.4 homework, but then this one got picked out of 5.5. So it does use U substitution. So this is the innermost function, so I'm going to try and let that be the u. So let u equal the 9 minus x to the 9th. And now take the derivative. So of course the derivative of 9 is 0. The derivative of x to the 9 will be 9x to the 8. Negative 9x to the 8, and then dx. So as you can see, this has the 8x to the 8, and this has the dx and x to the 8. This has the dx and x to the 8. So I just need to get rid of this negative 9. So multiply both sides by 1/9. And then it's ready for the U substitution. So this top part is going to get replaced with the du and the negative 1/9. I prefer to just factor out the negative 1/9, and then the top has the du. And the bottom, this is going to be u squared. And then I'm going to rewrite this as u to the negative 2. And then you can add 1 to the exponent, which makes it a negative 1, and then divide by negative 1. So this negative and this negative are going to cancel. That will be 1/9. And then what's left right here is u to the negative 1. And don't forget the plus c. And just like with the last one, I don't want to leave a negative exponent. And I also need to replace the u with the 9 minus x to the 9th. So I'll do that all at once. Getting rid of the negative exponent means the u goes in the bottom. And then replace the u with 9 minus x to the 9. And then plus c. Okay, then on to homework that is in section 5.5, and then they call it 5.6. So that's basically because in 5.5, they, in their programming way they set it up, 5.5 is U substitution, and then 5.6 is U substitution with trigonometry. So in here, basically I could let u equal either the tangent or the secant? Well, the derivative of secant is secant times tangent, which actually does show up in this problem. If I let u equal the tangent, then the derivative of tangent is secant squared, which actually is showing up right here. So I think I'm going to go for the u equals tangent. So let u equal the tangent of x. The derivative of tangent is secant squared, which means that this is matching this perfectly. So the 2 can stay there. Then this is going to be the u, and this is going to be the du. So basically we're doing integral of u, and this little 2 right here, I'm just going to factor it out. And then this is the u, and this is the du. And notice right now, I do not put the numbers because these numbers are for what x equals. So I'm going to finish the u substitution first, and then I'll put the numbers back on. So this one's exponent is a 1. So if you add that 1, that's going to be a 2 and divide by 2. Just so happens that 2 and that 2 are going to cancel. So all we get is u squared and the 2's cancel. And I don't put a plus c because we're going to have numbers to plug in. So there will be no plus c. It'll just be a numerical answer. And then replace the u with tangent. So that means that it is tangent squared of x. And now that the x's are back, then put the limits negative pi over 4 to positive pi over 4. And then substitute pi over 4. So this is going to be tangent squared of pi over 4, and then minus tangent squared of negative pi over 4. So remember, it always goes the top one first and then the bottom one second. So what is tangent squared of pi over 4? So it's in radian, that's good news. Tangent of pi divided by 4, when you square that, it equals just a 1. And then tangent of negative pi divided by 4, when you square that, is equal to a 1. And then just carry down this minus sign, and 1 minus 1 equals 0. And then another one. Sorry, the pages were stuck together. So this is in section 5.5. It's question number 6. It does have trigonometry, so in their numbering it comes from section 5.6, but it is part of the U substitution homework. So one thing to notice is that this has sine of 2t and this has cosine of 2t. That is good news, because if one of these only had t and the other one had 2t, we would have to use some trig identities. But since they're both 2t, that's good news. We can just go ahead and try the U substitution. And I would let u equal what's inside the parentheses. Sometimes with the U substitution, you just have to make a guess and try it. And if it doesn't work, then just use an eraser and pick something else for you. But I'm going to try this. So when I take the derivative of that, of course, the derivative of 1 is 0. The derivative of sine is cosine. And then I'm going to emphasize that this 2t is inside of the trig function. And then do the chain rule. So the derivative of 2t will be 2, and then dt, since t is our variable here. And then this problem has cosine of 2t dt, but it doesn't have this 2. So I'll just multiply both sides by a half. And then I have cosine of 2t dt, which is matching this perfectly. And so that means it's going to be integrate. And then I let this whole thing be u. So this whole thing in the parentheses is the u. Guess I didn't need parentheses. Well, that's okay. And then there is this cosine part. All of this gets replaced with just 1/2 du. And the 1/2, I'm just going to factor out. And there we go. So since this one has an exponent of 1, you can add 1 to that and then divide by 2. Now in this case, these are not going to cancel because both of these 2's are in the denominator. So that means that it's basically a 1/4 and then u squared. And then again, I don't put a plus c because there are numbers to plug in. And I still need to change this back to this. So basically we have 1/4 and then 1 plus sine of 2t being squared. Oh, I put my square in the wrong place. It's not the sine is being squared, it's the whole thing is being squared. Good thing I've got an eraser right there. And then evaluate it from 0 to pi over 4. So if I just do this part, basically I'm just going to keep this 1/4 factored out. If I just do this part, it's going to be 1 plus sine of 2 times pi over 4. And then whatever that is, I have to square it. So inside here, that is a 2. Square it is a 4. Take 1/4 of that and it equals 1. And then when you use a 0, that would be sine of 0, and sine of 0 is 0. So that means you would just have 1 plus 0, so that's just a 1. Square it is just a 1. Then multiply that by 1/4. So that's going to be 1/4. So minus 1/4. And then that equals 3/4. And then just for extra fun, I'm going to use the calculator and see if I got this one right. So the original problem was, you know what, you can do it on the graph, but you can also go to math and then go down to number 9, the function integrate, and then tell it integrate from 0 to pi over 4. And then I'm going to need extra parentheses. An extra parenthesis, 1 plus sine of 2. And you could use t on the calculator if you want to, but it's easier to just use x right here. And then I need also a parenthesis. So that's that parenthesis right there. And then times cosine of 2x. And then tell it that it's dx. And it says the answer is 0.75, which is the same as 3/4.